All right, hi guys. So I'm going to be doing this weekly where you guys tell me what questions you need extra help with on either the homework or the quizzes, and I will go over them with you. So I got a lot of questions from the week one homework, and one thing I've noticed with ChemVantage is the homework tends to be a little tougher than the quizzes, which in a way is good because they also do offer the option to show you how to work out the problems, and you can still go back and put in your answer to get full credit. So you should be able to get full credit on the homework assignments. It's unlimited attempts. You can do it as many times as you want, get as much help as you need, and take your time on it. And the quizzes are also unlimited attempts, so please keep that in mind as well. Okay, so one of the first questions I had a few people asking was converting temperatures. So I picked this question out where it wants you to convert a temperature in Fahrenheit to Kelvin. One thing I also want to stress is that I may have different numbers than you. The system randomizes numbers so that no two students' questions are the same, which also goes for the quiz. There's actually a bank of questions that it chooses for the quiz. So your quiz may look different from someone else's. All right. Nonetheless, the way to go through these should be about the same. So the first question, convert the temperature negative 179 degrees Fahrenheit to kelvins. For some reason, when it copy pasted over, it didn't put the little degree sign for Fahrenheit, but that's okay. Write pen a little less thick. I'm extra, so I gotta use my glittery pen, you know? We're gonna use the Galaxy pen this time. So we are given negative 179 degrees Fahrenheit. And we want to get to kelvins, but we really can't do that directly unless you combine a bunch of or two different systems of equations, which you could do, but I prefer to do things one step at a time. So the first thing we should do is go from degrees Fahrenheit to degrees Celsius, and then from there we can go to Kelvin. So the first part to do, degrees Celsius, when you look in your book, it does give you the conversion equation, or it's also in the lecture slides. So our temperature in Celsius is equal to 5/9 times our temperature in Fahrenheit minus 32. So we're going to plug and chug into that. So we have 5/9 times negative 179 minus 32. Oh, and my cat is currently trying to play with me. She thinks my arm is a play toy, which is so much fun for me. She's a kitten, so to be expected. So then that gives us 5/9 times negative 211. And then that in turn gives us negative 117.22 degrees Celsius. Now, if we're talking significant figures, this should be just negative 117 degrees Celsius. Because when you look at this, we were doing adding subtracting with the negative 179 minus 32. There's no decimal points there, so our final answer there would be 0 decimal points. So we're going to change it to that guy. And now to go from Celsius to Kelvin, our temperature in Kelvin is equal to our temperature in Celsius plus 273.15. So that is negative 117 plus 273.15. And remember, kelvins can never equal less than 0, so it should be a positive number. And accounting for significant figures, we're not going to have any decimal places because 117 does not have any. So we get 156 Kelvin for our answer. So that is our first question. Our next question, we are given a density of gasoline, and we want to know how much 21.5 gallons weigh in kilograms. So one thing with densities, we can think of it as a conversion factor. There's a couple different ways to do problems with density. Some people prefer to use density equals mass over volume. And if you want mass, then you multiply both sides times volume, and mass equals density times volume. And if you want volume, it equals mass divided by density by solving for V. And that's perfectly fine too. I like to use density as a conversion factor. So we can rewrite it as 0.774 grams for every 1 cubic centimeter. And if need be, we could also say that 1 cubic centimeter weighs 0.774 grams. So this is how you can use it as a conversion factor. Boom, there's 2 conversion factors that you can use depending on what you need and how you need to cancel things out. So we're starting out with 21.5 gallons. And we want to go ahead and convert this to cubic centimeters. Now, you can go ahead and Google gallons to liters or gallons to cubic centimeters, whatever you want. What I decided to do is do multiple conversions based off of what your book gives you. And I'm sorry, my kitten is literally going insane right now. Okay. Sprite, go take a nap, please. All right, so we know there's 4 quarts in every 1 gallon. And then our book tells us that there's 1 liter for every 1.0567 quarts. We can see here gallons are canceling, quarts then cancel. Now we have liters. And we know there's 1 milliliter per 10 to the negative 3rd liters. You could also rewrite that as 1,000 milliliters in 1 liter, whatever you want. But that 10 to the negative 3 liters is how it's said in your book. And then we also know that 1 cubic centimeter is the same thing as 1 milliliter. So we plug all this in and we get 81,385 cubic centimeters. And now that we have that, we can convert to grams using our density. Because we know there are 0.774 grams for every 1 cubic centimeter here. And then to go ahead and convert to kilograms, there are 1,000, oops, sorry, not 1,000, there's 1 kilogram. If you can hear all that little noise, it's my kitten running under my computer and around my computer and just being a jerk. But that's what kittens do, right? 1 kilogram per 1,000 grams. So we can see units canceling here, and we are left with kilograms, and you get 63.0 kilograms. I'm going to rewrite it because Sprite just smacked my hand and is making life very difficult on me. 63.0 kilograms. And by the way, yes, I will be posting this Word document on Canvas for you guys. I will save it as a PDF also, so it's more accessible. You quit rabbit kicking my hand, you little shit. Okay. So the next one, I picked this one. I didn't really get many questions on it, but I thought it was a good one because we're converting multiple things at the same time. So we're going to look at this. We're told the price of gasoline in Belgium is €1.81 per liter, and we're told that €1 is the same as $1.26, and we want to take this to cost of dollars per gallon. So we can start by writing down what we know. They tell us that €1 is equal to $1.26. Whoop, not 2. $1.26. And then I went ahead and used the Google. You can use Google. It's nothing stopping you from it. And it tells us that 1 gallon is the same as 3.79 liters. So we've got the 2 main conversion factors we need. So let's go ahead and go with what we're given. We're told €1.81 per 1 liter. Sprite. She's biting my laptop. She really wants my attention. Okay. so we're going to go ahead and start by converting that. And we can start with the dollar part. Why not? So we know there's $1.26 for every €1. And so we can see the euros there are canceling out. And she just threw my notes on the ground. When you're making videos, I highly suggest locking your cats in a different room if you're able to. However, if you're like me and you're at your parents' house helping them out with things, there is no place to lock your cat away because you're sleeping on the couch. All right. Anyway, so that gets rid of the euro portion. And now we have this liter to deal with. So we want to go from liters to gallons. But notice that liters that we're canceling out is in the bottom, which means to get rid of it, we need to put it up top. So we can put this 3.79 liters up top and 1 gallon in the bottom because that's where I want it also. I want it to be dollars in the numerator, gallons in the denominator. So then when we plug all this into our calculator, we get $8. Oh gosh, right. $8.64 for every 1 gallon. That is some expensive gasoline, right? And we complain about prices out here. But in Europe, a lot of people walk. So I've been to Europe a couple times, been to Greece and Sweden, and not gonna lie, I kind of miss it. All right. So that is that one. And now we are moving on to one that I've gotten a lot of questions on. Composition of C4 is a plastic explosive, and we're given a density. And we're told we have a mass of it and its measurements, and again we want the mass. Now, one of the first things I want to point out is it doesn't say what units to put the mass in, but when you look in the answer spot, where the blank is, next to it is kilograms. So we're going to want to make our mass in kilograms. So make sure you check that if they don't specify a unit. You see if they're being sneaky somewhere. So what we should first do is calculate the volume of our brick. We're given the dimensions, and we know that the volume of a brick or a rectangular prism, we're just going to assume it's perfect, is length times width times height. So that means it's 86 millimeters times 96 millimeters times 280.0 millimeters. Now, if you want, you could convert each of these millimeters to centimeters right away. I'm going to do it a little differently just to kind of show you another way of some conversions. So this gives us 2,311.68 centimeters. Not centimeters. I jumped ahead of myself. Spoilers. Sorry. 2311680 cubic millimeters. Now, technically, this should be 2 significant figures, but a lot of times when you're doing math, you want to wait till the end to do your rounding. So I could remind myself, I might put 2 SF here just to remind myself at the end, this needs to be 2 significant figures. So the 86 millimeters, that's 2, 96 is also 2, 280.0 is 4, so our lowest number is 2 sig figs. So just to remind myself, but sometimes when you round too early in a problem, you start introducing a lot of rounding error, and then your final answer ends up being pretty far off. So it's good to wait till the end for things like this. Okay, so now we have our volume in cubic millimeters, but I need cubic centimeters based off of the density I'm given. So let's go ahead and convert that. So 2311680 millimeters cubed. Now I know from using a ruler that that 1 centimeter has 10 millimeters. Now I'm not done with my conversion though. Millimeters here cancels, but this is cubic millimeters. That's an awful looking 3. Now it looks better. So I can't just get rid of cubic millimeters. That would bring this down to millimeters squared. So I need to do this another time. 1 centimeter per 10 millimeters. That gets rid of the squared. And then one more time to get rid of all the millimeters and be left with cubic centimeters. Okay, so you could also do it where you write 1 centimeter over 10 millimeters. Stop biting the microphone, you brat. Sorry, guys. And then you cube the whole thing. You just have to remember to actually do that. I've had a lot of students who write this and then they forget to do it in the calculator. So I prefer to do it one at a time. Don't worry, guys. I'll make a video holding Sprite or showing you her one day. Just not today when I look like a mess. Pretty quarantine mood, isn't it? All right. So now this gives us 2,311.68 cubic centimeters. Again, we can remind ourselves 2 sig figs. I'm going to erase this right here so I have room. Okay, so now we have cubic centimeters. We can go ahead and get mass. So we have 2,311.68 cubic centimeters. And we're given a density where we can put that as 1.05 grams for every 1 cubic centimeter. And then our answer needs to be in kilograms. So we know there's 1 kilogram per 1,000 grams. Cancel, 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 cancel. And we get, and then remember 2 sig figs. 2 sig figs is going to carry on to be our final significant figures. So we get 2.4 kilograms. All right, and now for the doozy. The mass of a star having a diameter of 4 times 10 to the 5th kilometers and an average density of 1.2 grams per cubic centimeters. Now this one actually isn't as bad as it looks. I think the main problem with it is if you're trying to put things in scientific notation, keeping track of decimal places, as well as maybe the volume of a sphere, because we're given a diameter. So first things first, let's go ahead and convert this kilometers to centimeters. So we have 4 times 10 to the 5th. I also want to stress that when you see e to the 5th, or you might see exp or ee, all of these mean the same thing as saying times 10 to whatever power. So e to the e5, exp5, ee5 is the same as saying times 10 to the 5th power. I'll be doing another kind of tutorial video on using a calculator soon, or I might just post some actually I might post some slides that I've made in the past that should be probably enough for you guys. Nonetheless, let's get to this. So 4 times 10 to the 5th kilometers. And I know there's 1,000 meters for 1 kilometer. And then there's 100 centimeters for every 1 meter. So I went ahead and did it this way instead of doing 1 meter per, or 1 centimeter per 10 to the negative 2 meters. It doesn't matter. It'll give you the same exact answer. So this comes out to 4 times 10 to the 10th power in centimeters. Now, this is our diameter. The volume of a sphere, we're going to assume the star is a perfect sphere, is 4/3 pi r cubed. R being the radius, and remember the radius is half of the diameter. So this is 4/3 pi times 4 times 10 to the 10th divided by 2 cubed. So once you put this into your calculator, you're going to get 3.35 times 10 to the 31st power. And that is cubic centimeters. And now we can use density to convert to grams. We're given a density of 1.2 grams per cubic centimeter. That's kind of a light star when you think about it, because the density of water is 1 gram per cubic centimeter. So it's not even that much denser than water. So 3.35 times 10 to the 31st cubic centimeters times 1.2 grams per 1 cubic centimeter. And then when you look at the answer space, it wants our answer in kilograms, and there is 1 kilogram per 1,000 grams. And this should be technically 1 sig fig, because we're only told 4 times 10 to the 5th power. So this would be, first I rounded it to 4.02 times 10 to the 28th kilograms, but to 1 sig fig would be 4 times 10 to the 28th kilogram. And then we are done. So I hope this helps you guys and that it answered your questions. If you have any others, please let me know. Shoot a comment, shoot me an email, use the Q&A forums, whatever it is may be that helps you out. I know conversions can be a little confusing. This is why I set them up the way I do. You can see your units canceling properly and make sure that you're getting to the right place. It's a hard thing also to just kind of teach virtually instead of in person. But please know you can contact me. We can do a Zoom meeting if that would help you. Whatever it is that may help you enhance your learning, please know I am here to help you. I am available pretty much all hours of the night and day. All right, guys, I hope you have a wonderful weekend. You get some rest and you keep kicking butt, and I will see you soon.